basics, so we'll take a look at all the things that we have covered in this unit, right? So first consider a thyristor half-wave controlled rectifier. So in here you were given the AC supply, the RMS voltage, and the output is a 100 ohm resistor. Okay, so then you have to show that the average voltage of the rectifier is given by this equation. Okay, so how to find the average? So in this half wave rectifier, this is the original waveform that we have, and we can draw the so here this part will not be there, right? And this it will go, and here this is the angle alpha, and here this is 2 phi, and here it is 0. Right? So we have to integrate and find the area and divide by 2 phi. So therefore here so this is this waveform, this is actually Vm sine theta, or we can write it as Vm sine omega t or anything. Here this is omega t or theta, right? The same thing. So therefore average it is equal to 1 over 2 phi, integrating from alpha to phi, Vm sine theta d theta. So Vm can take out, and if we integrate sine theta, it will be minus cos theta. From phi to alpha you have to substitute the limits. So when you substitute the limits, you will get minus cos phi plus cos alpha. Right, so minus cos phi means actually plus 1, so you will get this answer, right? So then you are asked to determine the average values of the load voltage and current when the firing angle is this. Right? So therefore just substitute to this alpha equal 30. Here Vm is equal to root 2 into Vrms. So in our case Vrms is 240, so Vm is root 2 into 240. Okay. Then here we have 2 phi, then 1 plus cos alpha, 1 plus cos theta. You will get the answer like this, right? And if we take this as our V average, and this is I average, and this is resistance R. So I average is equal to V average divided by R. So therefore you will get I average value like this, right? Then alpha equal 140. So in here the average voltage should be very much less, because it is very much close to 180. So only like 40 angle of 40 will be the thyristor will give the output. So again the same thing, substitute for Vm, and we have 2 phi 1 plus cos 140. So you will get 12.6. So considered with alpha equal 30, this is very much less value, and again we can calculate the I average value. Right. Then we need to calculate the RMS value of the output voltage, right? So Vrms, it is equal to square root 1 over 2 phi from alpha to phi Vm sine theta, and the square of that one you have to integrate with respect to d theta, right? So if you square this okay, so if you you can do the you can find the Vrms, right? Vrms, which is equal to Vm over 2, and you'll get this answer, right? So for this one, in order to simplify, you may have remember we have done this one also, right? We will use the identity sine square theta, we'll substitute as 1 minus cos 2 theta over 2, right? So Vrms, it is equal to Vm within the square root 1 over 2 phi from alpha to phi 1 minus cos 2 theta over 2 d theta. Here inside this we had Vm squared. Okay, Vm squared we have, right, because of this square, and when we take it out it will become just Vm. Then here 2 and 2, so we can take it out like this, right? Then if you integrate 1, you will get theta. If you integrate cos 2 theta, you will get sine 2 theta over 2, right? Then substitute these limits alpha, phi and alpha, so theta will be phi minus alpha, and here the sine 2 theta, because sine 2 phi you will get it as 0, so you will only get like sine 2 alpha over 2, right? Then divide everything by phi and you will get this answer. So as I have remembered you when we are doing the previous tutorials also, in here you have ratio of alpha of phi, so basically you have to substitute, like let's say for alpha equal like phi over 6, which means 30. So in order to find this, you should use either decrease or either radians, right, for both phi and alpha. So here consider when the firing angle is alpha equal 30, determine the RMS value of the current. So again, okay, Vm is equal to root 2 into 240 divided by 2, right? Then 1 minus, here this is alpha and here this is phi, right? Sine 2 theta divided by 2 phi, which will get this value, right? And again here this is the Vrms and here this is the Irms and the resistance is R, right? So the here even though we are converting this one from AC to DC, so this one what we are doing is we are converting from AC to DC, the output signal, it is not since we have resistor in here at the output, the output voltage and current, they are not smooth DC values, right? So they are actually some waveforms which will have only positive values, right? So they will not alter, so therefore they are not AC current, but they are not smooth DC, so that's why we will have a RMS voltage and RMS current. So therefore Irms you can calculate as Vrms divided by R, which is 167.3 divided by 100, so you will get this value. Then how to calculate the power of the load? So here the current going in here is Irms and resistance is R, so you will get it as R into Irms squared, right? So substitute the values, then you will get the power of the load. So then in order to calculate the power factor, here we have the P value, which is 240. In order to calculate S, right, what you will do is you will multiply the Vrms 240 and the current Irms, which is 1.673. So this is S and this is P. So if you substitute, you will get the overall power factor as 0.697.